finish off solving right triangles, we're going to look at some applications. Applications always involve story problems of some sort of diagram maybe, and it's usually going to be helpful to draw a diagram. Okay, so I've got this situation drawn up here just because we've got hunting season coming up in the fall here, and so did a little diagram of a situation you might see. Here I have a tree stand, someone hunting deer, I guess, and a bait pile, and we've got some measurements here. And so I always found it interesting, if you had a 20-yard shot to a bait pile, how long, or 20 yards from the base of your tree, how long is the actual shot? Because the actual shot is the hypotenuse of the triangle, whereas usually you think about your distance from the base of your tree, along the ground. You can measure that easily, usually by pacing it out. And so let's say a person had set up their bait pile to be 20 yards from their tree. Standing at the bait pile, there's a 14-degree angle from horizontal up to the height at which the shot would be taken from. And so the question then is, what is that distance along the diagonal there, along the hypotenuse, that the actual shot is taken from? Okay, so what is the actual distance of the shot, not just the distance between the tree and the target? And so to find that, usually with these applications, you're only going to be looking for one of the other sides or one of the other pieces of information from the triangle. So here I've got three pieces given. I've got the right angle. I can even draw this in. There's a right angle down here. That's always going to be given in a right triangle. You've got one angle, other angle, and you've got one of the sides. And so in this one, instead of trying to find all three other pieces of information, we're only looking for one. Okay, most of these story problems, you're only focusing in on one of them and trying to find it. And so in this particular case, I'm going to call this side S for shot, I guess. It's the distance of the actual shot. And so I'm going to convert everything into feet, because I think it will be a little bit more accurate to deal with feet rather than yards in this one. So 20 yards is the same as 60 feet because there are 3 feet in a yard. Okay. And so to find the shot distance, we're going to use, think about the angle here is 14. The two sides in play are the adjacent side and the hypotenuse. Well, what trig function corresponds an angle to its adjacent and hypotenuse? Well, it's the cosine, right? The cosine of an angle is equal to the adjacent side over the hypotenuse, okay? And so that gives us a relationship that we can solve for S, solve for this hypotenuse. So I'm going to go ahead and multiply both sides by that denominator. Whenever we have that fraction in there, it's a good way to start. So we multiply by the denominator. The s's cancel on the right. We're left with s times the cosine of 14 degrees is equal to 60. And then I can divide by the cosine of 14 degrees. I'm going to do that to both sides of this equation. That will solve for the s. So divide by cosine 14, divide by the cosine of 14. Now I'm going to type this into the calculator to get an answer. And so s is going to be equal to 60 divided by cosine parenthesis 14 parenthesis. That's how this should look when I type it into the calculator. 60 divided by cosine 14 looks to be 61.837 roughly. Of course, I would probably round this off to the same number of significant figures as in the original, so probably no decimal places here. I just leave it to the nearest whole number. And so I'd probably call this 62 feet, okay? So being up at this height in the tree, you're really only lengthening your shot by 2 feet, even though it's a hypotenuse versus a horizontal leg of a triangle. It's not that vast of an increase in the distance. It's not even a full yard, okay? So the actual shot then is 62 feet. That would be a good answer there. Now, I'm curious how high that tree stand is in the tree. I guess the tree stand plus the height of the hunter as they're shooting, because that's kind of where this angle was measured to, the position of the shot. And so that might be an additional piece of information you could find that I wasn't asking for it originally, but we could look for that. And of course you could find that using, say, the Pythagorean theorem, or maybe even to be more accurate, I'll call this the T for tree stand, maybe height of the tree stand. And so that's from a 14-degree angle, that's the opposite over you could do over the adjacent or the hypotenuse, whatever you want. I like to go back to the original information given. So that height could be found using the tangent, right? So the tangent of 14 degrees is the opposite over the adjacent. And if I then multiply both sides by the 60, multiply by 60, we'll get the value of t. 60 times the tangent of 14 equals t. And of course I could type that into the calculator. 60 tangent 14 parenthesis looks to be about 14.95968, just under 15. So t is approximately 15 point, what did I say, 9596 8 and so forth. That's our decimal. So if I were to round this off, you're basically looking at a height of, wait, did I say, oh, it's 14, sorry, not 15. It's 14.95968 and so forth. So if we round this off to the nearest foot, we're looking at a 15-foot height for the height of the elevation of that shot being taken. Okay, so T is really more like 15 feet. Okay. So again, this gives you an idea of how to solve just for a single piece of information. We're not looking to solve the entire triangle. In these applications, you're just looking for a specific part of the triangle, maybe a side, maybe an angle, just depends on the problem.